In addition to visual models for representing ratios, there are a number of numerical models that can help represent ratios too. These numerical models can sometimes help you solve problems involving ratios. In this video, we'll look at some examples. A tropical punch recipe has 2 parts orange juice and 3 parts pineapple juice. How much of each type of juice will be needed to make 25 gallons of punch? The ratio of orange juice to pineapple juice is 2 to 3. We need to find out how much of each juice is needed to make 25 gallons of punch. To solve this problem, you can use a double number line, as shown here. With a double number line, you keep track of the ratio and expand each term in the ratio using a number pattern. Let the top number line represent orange juice, and let the bottom number line represent pineapple juice. Start with the basic ratio 2 to 3. At the bottom, we will keep track of the total number of each. So at the start, we have 5. We increase the value of each term on the number line based on the starting numbers. So on the orange juice line, the next number is 4. While on the pineapple number line, the next number is 6. The total now is 10. Remember, our goal is to get to 25. The next value on the orange number line is 6, while on the pineapple, it's 9. The total is now 15. The next value here is 8, and here it's 12, for a total of 20. We're almost there. The next value here is 10, and here it's 15. The total is now 25, which is our goal. So to make 25 gallons of punch, you need 10 gallons of orange juice and 15 gallons of pineapple juice. Now let's look at another example. At a fruit stand, the ratio of bananas to apples to oranges is shown in this illustration. If there were 40 fruit, how many oranges were there? This is a 3-item ratio of 1 to 4 to 3. For bananas, apples, and oranges. To solve this ratio problem, we can use a ratio table to generate sets of numbers that maintain the ratio. Like this. In the first column, we add the 3 items: B for bananas, A for apples, and O for oranges. In the second column, we add the ratio 1 to 4 to 3. Below the table, we'll keep track of the total number of fruit, which at the start is 8. With a ratio table, you increase the amount based on the values in the ratio. So in the next column, we have 2 for bananas, 8 for apples, and 6 for oranges. Each value increasing based on the ratio value. The total here is 16. We want the total to be 40, so keep adding values that maintain the ratio. The next column has 3, 12, and 9, for a total of 24. The next column has 4, 16, and 12, for a total of 32. Finally, with the last column we get 5, 20, and 15. And this gives us a total of 40, which is what we were looking for. This means there will be 5 bananas, 20 apples, and 15 oranges. While this might be a long way of finding the answer, using a spreadsheet can quickly generate a ratio table. Just make sure that the values increase based on the numbers in the original ratio. Let's look at an example where we can get to a result in fewer steps. A farmer grows corn and wheat. For every 5 pounds of corn he grows, he also grows 12 pounds of wheat. If he grew 3,000 pounds of wheat, how much corn did he grow? The ratio of corn to wheat is 5 to 12. And the two components of the ratio add up to 17. We want the value for wheat to be 3,000. So using a ratio table would be too cumbersome to use. But we can use a variation of the ratio table, but one that uses multiplication. Here is the table. In the first column, we label the items C for corn and W for wheat. In column 2, we write the basic ratio, 5 to 12. We know that the new value for wheat is 3,000. So we add it here to the table. To go from 12 to 3,000 involves multiplying by 250. To find the corresponding value for corn, multiply 5 by 250 to get 1,250. The ratio of 1,250 to 3,000 maintains the basic ratio of 5 to 12. So the farmer grew 1,250 pounds of corn.